Hey everyone, welcome back to The Explainer. This is the educational series brought to you by Forge College, and I am absolutely thrilled to be your host today. We're diving into a brand new topic on our blockchain fundamentals track. We've been exploring the deep philosophy and the practical trust mechanisms of Web3, and today, well, we are unpacking a concept that is quite literally reshaping how we build the internet. Get ready because we're looking at permissionless innovation.
Okay, let's dive into this. Have you ever tried to get into a super exclusive club? You know the drill. You're standing in line, you're waiting for the bouncer with the velvet rope to check his list, look you up and down, and finally decide if you're actually worthy of entry. That friction, that gatekeeping, is exactly how traditional tech ecosystems often work. You need developer accounts, you need API approvals, corporate blessings just to build something. But what happens when that bouncer goes on an indefinite vacation, takes the velvet rope with him, and the doors are just left wide open? Well, Web3 is that wild, open frontier where anyone could just walk right in and start building. Literally, no permission required.
Now, if you've been following along with our courses at Forge College, you might remember our previous lesson on the foundations of digital privacy. In that explainer, we talked all about data minimization and pseudonymity, which is basically the art of not leaving your digital fingerprints everywhere. And those foundational privacy practices are absolutely crucial here. Why? Because when you step past where that velvet rope used to be and enter a system where anyone can experiment freely, you're operating entirely in public. The rules of privacy completely change when there are no gatekeepers around to protect or, exploit your data.
So let's define exactly what it is we're talking about. Permissionless innovation describes systems that allow new participants, services, or contracts to appear and interact without any prior authorization. It is literally the engine for rapid iteration. By radically lowering the barriers to entry, anyone, from a college student in a dorm room to a massive global enterprise, can deploy code on the exact same footing. There's no waiting period, there's no board of directors to stamp a big red no on your project. It's just pure, unadulterated, community-driven experimentation.
Section 1. Welcome to the Open Lab, a mental model. And this brilliantly illustrates our core mental model for today. I want you to stop thinking of a blockchain as some boring database and instead imagine it as a massive public scientific laboratory. Picture this open lab. It's fully stocked, totally free to use. First up, you've got the shared instruments. These are the protocol and consensus mechanisms, basically the standard beakers and microscopes everybody uses. Then you have the public notebook. That's the blockchain ledger itself, where every single result and measurement gets written down in permanent ink for eternity. Finally, you have the common bench. These are the network rules that govern how you place your experiments down. It makes the whole abstract concept incredibly tactile and intuitive, right? Everything is available to everyone.
Whenever you're looking at a new protocol or project in this lab, you really need to assess it using these three evaluation axes. Number 1, visibility. What exactly is being written down in that public notebook for all to see? Number 2, control. Who is actually allowed to place their experiments on the bench in the first place? And number 3, composability. How easily can my experiment be mixed with your experiment? Keeping these three axes in your back pocket will really help you quickly reason about the privacy implications and figure out just how fast innovation can happen.
That third axis, composability, is where things get wonderfully wild. Composability multiplies combinatorial innovation. You take my protocol, you mix it with your token, and suddenly, boom, we have a brand new financial instrument. But it also multiplies privacy surfaces. Think about it. In a real public lab, if you accidentally mix the wrong reactive chemicals together, you get a massive explosion. In Web3, those accidental explosions happen when the outputs of one experiment unexpectedly feed into another and instantly expose sensitive data to the entire room. Privacy gone. Seriously, grab your safety goggles for this stuff.
Section 2. A community payment experiment. A real-world example. Let's move to and see how this builds in a concrete real-world scenario. Let's walk through the rapid life cycle of a permissionless deployment. Step 1. A small team deploys their payment contract, essentially their raw computer code, directly to the network. No central coordinator, zero red tape. Step 2. Users immediately start sending transactions, opening payment channels, and moving value around. Step 3. Because it's a public lab, third parties instantly start writing monitoring tools to parse events, detect anomalies, and build analytics. This total lack of a gatekeeper creates a hyper-fast cycle of patching and tooling. It's collaboration on fast forward. But of course, here is the privacy catch. Public logs combined with off-chain identities equals a massive privacy exposure. Think of it as having a highly nosy lab partner just hovering over your shoulder all day long. If you decide to go on a public forum and say, hey everyone, here's my wallet address, send me donations, well, congratulations. You've just linked your real-world identity to every single payment channel activity you've ever done in that public notebook. The Open Lab sees all, and trust me, it never forgets.
So if there isn't a traditional safety review board to protect us, what keeps the lab from just burning down entirely? Well, we rely on social and economic controls. We use community audits where developers review each other's code. We have bug bounties that financially reward hackers for finding flaws before they can be exploited. We lean heavily on reputation systems. And honestly, if things go really, really wrong, the ultimate mitigation is a fork. The community literally just takes the open source code, fixes the fatal flaw, and walks away to start a brand new lab of their own. It's an amazing organic immune system.
Section 3. Permissionless versus permissioned models. Open versus closed systems.
To really grasp the sheer power and the danger of the Open Lab, let's step outside for a second and compare it to a closed, highly controlled corporate facility, because this is the fundamental architectural difference. In a permissionless model, there are no gatekeepers. It is open participation, raw and completely unfiltered. In a permissioned system, you have a trusted authority. You've got identity checks, access control lists, NDAs, corporate badges, the whole shebang. It's basically the difference between contributing to Wikipedia and trying to go rewrite an article in the Encyclopedia Britannica.
Now, what's really interesting about this slide is how incredibly clearly these trade-offs map out. Look at the deployers. Literally anyone versus authorized parties. Look at the speed, fast, rapid, wild experimentation versus slower, centrally reviewed rollouts. And then look at the privacy risk at the bottom there. Permissionless definitely has higher on-chain exposure, while permissioned has lower exposure, but it entirely requires you to trust the gatekeeper. Remember, permissionless doesn't mean no privacy. It just means your approach to privacy has to be fundamentally different.
Section 4. Mitigating your privacy risks. Protect your privacy. Okay, so how do we actually survive and thrive in this environment? Because the protocol is not going to automatically protect your secrets, you have to be totally proactive. First up, minimize your on-chain identifiers. Just don't put data on the ledger unless it's absolutely necessary. Second, prefer ephemeral addresses. Think of them as burner accounts for specific experiments so your whole financial history isn't permanently linked to one single alias. And third, use strong off-chain protections, like zero-knowledge proofs. A zero-knowledge proof is basically cryptographic magic that allows you to prove something is true, like proving you have enough funds for a transaction without revealing the underlying data itself. You absolutely have to be your own privacy advocate.
Section 5. The Innovation Trade-off. A core philosophy.
As we wrap up our time in the lab today, we need to synthesize everything we've learned into one core philosophical takeaway. So, the crucial point is this. Open systems trade centralized control for distributed visibility. You are giving up the safety net of a corporate bouncer, but in return, you get total, unpermissioned freedom to build. It's a massive paradigm shift. The responsibility for security, privacy, and safety shifts entirely away from a centralized gatekeeper and lands right onto protocol design, cryptographic tools, and the community itself. It's incredibly empowering, but it absolutely demands your respect.
Of course, this open frontier creates some immense friction when it inevitably collides with real-world realities and adversaries. So, in our next explainer, we're going to dive straight into the deep end with privacy trade-offs and censorship resistance. We'll analyze concrete scenarios where this beautiful openness actually amplifies your risk and look at exactly how we fight back against censorship.
I'll leave you with this provocative question to ponder. If you ran a public on-chain experiment today, like right now, what traces would be visible to the entire world? Really think about your wallet, your data, your metadata. I highly encourage you to keep exploring these fascinating questions with us. Visit forge.college to learn more about this subject and access a wealth of other Web3-related topics and learning programs. I've been your host for The Explainer, brought to you by Forge College. Stay curious, stay secure, and I'll see you in the next Explainer.